we have a torque versus theta diagram for a certain engine or certain prime mover. This one is mean torque, and this diagram is drawn to the some scale. So this one is the area, it is slightly larger area. Then we have slightly smaller area. Then we have again a smaller area, again a smaller area, smaller area, and we almost very small area. This diagram is drawn purposefully. Let's call this area equals to A1. Let's call this area equals to A2. Let's call this area equals to A3. Consider this area. Now, as far as figure is concerned, you will find A1 is the largest and A6 is the smallest area. But remember, when I say concept of maximum and minimum energy, we are not able to measure absolute energy. But we can very well find out where we have difference between maximum and minimum. We are not able to measure the energy, but relative term we can do. Now, since we are interested to find out the difference between maximum and minimum, we are starting at point E. So let's assume at point A the energy equals to E. So let's say energy at A equals to E. With reference to this energy A, this area is positive area because it is above Tm. So is the energy at B is E plus A1. Actually, we don't know what is A1, but this is just a assigned value A1. But if you move from B to C, so can we find out energy of C with respect to B? At B, we have find out energy with respect to A. So we'll continue this series. So energy at C is it equals to B, which is equals to E plus A1. But this energy is negative, is minus A2. Now with respect to this, we are able to calculate at D. So energy at D, energy at C plus this value. This is plus value because it is above. So this one is E plus A1 minus A2 plus A3. Similarly, we have energy at E, that is E plus A1 minus A2 plus A3 minus A4. And finally, we have at F is equals to E plus A1 minus A2 plus A3 minus A4, and this time is what? Plus A5. And since we are coming from higher level to the same level at this point, so is the energy at G is same as energy at E. So energy at G must equals to energy at A. Out of this calculation, one of the energy will be maximum and one of the energy will be minimum. So that you have to find out numerically. So out of this, one value will be max and other value will be equals to minimum. This difference of energy is stored in the flywheel. We call this one as delta E. When you calculate E max and E minimum, and let's say that this one is max, let's say this one is max, and let's say this one is minimum, then is the term E will be cancelled out because if you subtract it, and only required is that A1, A2, A3, A4 cancel. We don't require E value. We only require the concept of area. So this one is delta E. The coefficient of fluctuation of energy, CE, is given by the maximum difference between energy E max minus E minimum divided by work done during the cycle, or this simply equals to delta E divided by work done. Power is defined as rate of change of work done. This equation in this form. This one is Tm multiplied by 2 pi, and this one is what? N by 60. Now check the unit of this one. What is n by 60? Is it per second? That is, this quantity, does it represents the dt quantity? Then therefore, is this quantity, does it represents work done? So this one is work done is equals to is Tm multiplied by 2 pi. But remember one thing, this formula holds good for calculating the mean torque. And if you want to find out work done, then always use the formula, this one, T multiplied by d theta. And in case of 2-stroke and in case of 4-stroke, in 2-stroke cycle is completed in 360 degrees, that is 2 pi radian. In 4-stroke it was completed in 720 degree, that equal to what? 4 pi. And therefore work done for 2-stroke is 2 pi multiplied by Tm mean torque. And this one is work done is equals to not 2 pi but 4 pi multiplied by Tm. This is the major difference. Okay, this is a particular T theta diagram, and in this case this value equals to what? Let's say this value is equals to 2 pi. He has given not to the scale, and this was given as 3 pi. Now to calculate this area, suppose this one is 400 torque and this one is 500 torque. So is the area under this diagram is equals to 400 into 2 pi is 800 pi plus this area, that equal to what? 500 plus 1 pi. 1 pi. So this area equals to what? 800 pi. 2 pi into 400 equals to what? 500 pi. So what is the work done right now? Is 1300 pi. Is it correct? But remember one thing, cycle will not complete at 3 pi, cycle will complete at 4 pi. So this portion they will never provide, never. You have to assume, continue this. Graph is okay. And if you want to find out the mean torque, then you have to take Tm multiplied by 3 pi or 4 pi. 4 pi. This one is pi. Pi cancel. Then what is the value of mean torque? Is 1300 divided by 4 pi or only 4. 650. They use the equation this form. T equals to torque at any time is dependent on crank angle theta. So this one is crank angle theta and this one is torque. Your value will fluctuate above 15,000 for sine of 2 theta minus cos of 2 theta. Now you remember sine 2 theta and cos 2 theta over the period of 0 to 2 pi, they are cyclic. Cyclic means they will rise and they will fall. So in this case, the diagram will become like this. And where you have sine theta and cos 2 theta equal to 0, that you can calculate. So if you equate this term, that is sine theta and cos theta, sine 2 theta is same as what? Cos of 2 theta. So if tan 2 theta is equals to 1. So 2 theta equals to 45. 45. So theta equal to what? 22.5. After every 22.5, the graph will going to cross this particular graph. So in this case, we do have a fluctuations like this. Is the rise and fall above this graph is always same. So in this case, if you want to find out Tm, so your answer is very straightforward. This is same as Tm. There is no point of Tm going by this equation, T times d theta divided by integral of d theta. The meaning of this one is mean torque, and the meaning of this figure is that is your torque is fluctuating about Tm. So is your torque is fluctuating about 15,000. So without solving, you can write this answer equals to what? 15,000. And you can save your valuable time. Not time, valuable time. Chalo. What is CS? CS is defined as omega max minus omega minimum upon omega mean. And what is omega mean? Is omega max plus omega mean divided by 2. That's it. Next term we are discussing is I. I is defined as mk square. Then we are defined C. C is defined as divided by work done. What is delta E? Delta E is defined as E max minus E minimum. बस ना और कुछ दिया? चलो इतना लिख. So okay, I will continue the last term. Is this energy stored in the form of kinetic energy? And kinetic energy is given by half I into omega max square minus 1 by 2 I into omega minimum square. So I can very well take out 1 by 2 common, I common, and what I get is omega max square minus omega minimum square. So this is my first formula. Can we write a square minus b square is equal to a plus b into a minus b? So this equals to 1 by 2 I omega max plus omega minimum into omega max minus omega minimum. A square plus b square, a plus b, a minus b. Now what to do is that I will adjust these two here. So if I adjust 2 here and this 1 by 2 cancel out, then is this term becomes omega mean. So I have another formula is I into omega mean multiplied by omega max minus omega mean. Now if you take a reference of omega max and omega mean from this case, can we replace omega max minus omega mean as CS multiplied by omega? So what I get is I multiplied by omega m. Is this term is CS? Is it multiplied by omega m? So my final equation for delta E is I CS into I into omega m square. Remember there is no by 2 in this equation, and in the first equation we do have by 2. The first supporting equation is power equals to 2 pi n multiplied by Tm divided by 60. In case of 2 stroke is 2 pi multiplied by Tm. Work done for 4 stroke is 4 pi multiplied by Tm. Delta T is equal to Ta minus Tm is same as I into alpha. That is this area, H area is delta T. So alpha equals to delta T by alpha. If alpha is positive, what do you conclude? Accelerate. And if alpha is negative, it retards. And your equation is supported by the Newton's law of motion, that is V is equals to U plus AT. This one is for translational. We'll use this for rotational. Final omega equals to initial omega plus alpha multiplied by T. And we have also known S equals to what? Ut plus half AT square. Now S translational, so in case it is theta. U equals to omega 0 multiplied by T plus 2 into alpha into T square. So can we find out how much angle it will turn before it comes to rest or what it may be?